All right, we're back. I'm on page 5 of note 7. There's nothing to do on this page. It is all just a summary of the tests we know so far: nth term, geometric, p-series, integral, comparison, limit comparison, ratio, root, telescoping, tons of stuff, right? So these are your primary weapons that you're going to use when you're trying to decide if a series converges or diverges. Advantage of the ratio and root test is that you take the absolute value of the terms, so the series doesn't need to be positive termed. For most of our tests, it actually needs to be positive termed. N term test for divergence, like who cares if it diverges, it diverges. Geometric doesn't care. R could be positive or negative, that's fine. Otherwise, like the tests themselves kind of like stipulate that things must be positive or greater than or equal to 0. As you can see, like, nope, here and here. Integral tests, the function needs to be continuous positive and decreasing, like a lot of positivity there. So ratio and root will allow you to deal with things that are sometimes positive, sometimes negative, that aren't just strictly geometric, but they'll also work on geometric if you don't have to find the sum. So let's see. Now we're gonna do these. They're just random problems. Apply one test to each of these, but identify all the tests that could be applied. All right. So A here. I mean, you could use the integral test. I'm not going to. Integral test. Nth term test doesn't work because the limit is 0. You can't use a ratio test because it's basically a p-series. You don't want to use a root test for the same reason. Do you not want to use a root test? Maybe the root test does work. Maybe. Let me fire up the old Inspire and see what happens there. So this might be an instance where the root test is better. I mean, the root test might always be better. I'm going to define a of n to be 1 over 6n plus 7. And then I want the limit of a of n to the 1 over n. Now, I think this is going to give me 1, right? Because the nth root of 6n is just a number. So I think this is going to give me 1. Oh, I forgot the n. And then I deleted that. And infinity. 1. Yeah, okay. Inconclusive. Lost my mind there for a second. Thought maybe something was happening that wasn't happening. All right, so integral test. I'm going to use the limit comparison. You could, I guess, 6n plus 7 is bigger than n, so like I would not do direct comparison. So I'm going to use limit comparison. Do the limit as n approaches infinity of 1 over 6n plus 7 over 1 over n is the limit as n approaches infinity of n over 6n plus 7, which is 1/6. Okay, so which is positive and finite. Positive, finite. Okay, so since we got something positive and finite, they do the same thing. So since the sum of 1 over n diverges, the sum of 1 over 6n plus 7 diverges by limit comparison. So that's how I would do that. All right, this one, geometric, to me looks like an obvious choice. The root test is a good choice. The ratio test, I think, will also work on this. So I think you could use ratio, root. Geometric is what I'm gonna use. I mean, I guess you can like always limit compare it to some other thing, but like I don't think we need to do that. So I'm gonna say this is geometric. R is equal to e over pi. So e is less than pi. This is less than 1, therefore converges. We can actually find the sum of this. So it's going to be e over pi. First term, so you plug in 1 and you get e over pi over 1 minus e over pi. And you could simplify that or whatever. I don't know. The root test would immediately give you e over pi, which is less than 1. The ratio test, I think eventually will probably also give you e over pi. Actually, maybe like immediately give you e over pi, and that's also less than 1. So all those are options. This one, nth term test for divergence, for sure. Not the ratio test, not the root test. I think I'm just going to use the limit as n approaches infinity, 3n over 4n plus 5 is 3/4, which is not 0. Therefore, diverges by nth term test. I don't know. You can maybe use the integral test on that. I don't know. Like if the nth term test works, it's like why are we going out of our way to find other things? This one, the limit is 0, so the nth term test doesn't work. Ratio test, I think, is going to be inconclusive. Root test, I don't even know, probably also inconclusive. I think I'm going to use the integral test. So I can't think what else I would do. I mean, well, this is bigger than 1 over n. This definitely diverges, right? So you could direct comparison, dircomp to 1 over n, because natural log is bigger than 1 eventually, so it's bigger than 1 over n. It's bigger than a diverging series, so it diverges. Limit comparison will not give you a positive finite. It'll just give you infinity, so you can't really do that. So direct comparison to 1 over n is actually probably the easiest way. Actually, I'm going to do that. You could also do the integral test. An integral test will also give you that it diverges. Obviously, it has to. So I'm going to say that natural log of n is greater than 1 for n greater than e. So natural log of n over n is greater than 1 over n for n greater than e. So since the sum of 1 over n diverges the sum of the natural log of n over n diverges by direct comparison. So like I shy away from direct comparison, even though sometimes it's the easiest thing to do. Like I was all in on the integral test until I realized like, oh wait, direct comparison is maybe easier here because the relationship is easy to establish. This ratio test. I think this is ratio test right off the bat. So I'm gonna do. What else would I use? I don't know. I don't know. I'm just gonna use a ratio test. Limit z approaches infinity. Absolute value. N plus 1 minus 3 is n minus 2 squared. N plus 1 minus 1 is just n squared. N minus 1 factorial. N minus 3 squared. Okay, so what do we get? There's still going to be n's involved, so still this. Don't need the absolute value because everything's positive because n is going to infinity. We got these are going to straight up cancel. That pretty much always happens. And then when we compare these, in the denominator, I'm just going to have an n and then n minus 1 factorial. N minus 1 factorial is canceled. We get 1 over n. This is 0. That's less than 1. Therefore, oh, there's a lot of these. Converges. Whew, geez, how many? Okay, we got this. This one, I might be inclined to use a ratio test. I think it'll work, so I'm gonna write that down. Ratio test. I wouldn't use, I don't know what else I would use. I'm gonna use the root test. Limit n approaches infinity. The absolute value of 2n squared plus 1. It's like the absolute value part is really easy to deal with when everything is positive, so you don't have to worry about the absolute value. I feel like that should probably be obvious, but we can drop the absolute value because everything's positive. And this just becomes 2n squared plus 1, 5n squared minus n minus 2. And then 2n times 1 over n is just 2. So this is 2/5 squared, 4 25ths, less than 1. Therefore converges. So this is really like, once you learn all the tests, you need to like do a lot of mixed random practice problems to like really get what's going. This one, I mean, there's no need. Am I coming to the conclusion that, I think I might be coming to the conclusion that if the n-term test for divergence works, there's no reason to even like think about anything else. This is not 0. Therefore, divergence by nth term test. Am I always naming the test? I don't know. No, I'm not. By ratio test. says by root test. I hope I did it for the other ones. Direct comparison, nth term test, geometric. Look at that. Good work. Good work. All right, this one, a lot of options. Limit compare to 1 over n squared, because it's basically 1 over n squared. It's going to do the same thing. So this converges. This is telescoping. So you could telescoping. It's telescoping. So you could do it. You could find the sum. I don't think I want to do that here because of time constraints. So I'm just going to decide if it converges or diverges. Do limit as n approaches infinity of 1 over, can't decide how to write it, n plus 1 over n squared equals limit as n approaches. I wish I'd flipped that to begin with. N squared over n plus 1, which is 1, which is positive, finite. So since 1 over n squared, oh gosh, you know, to like you rush a little, this converges 1 over n plus 1 converges by limit comparison. You could maybe do the integral test on this also, now that I think about it. Potentially, you can do partial, once you do partial fractions, like telescoping, I think you could probably do the integral test. I mean, I guess you must be able to. Is that a thing? Like if a series converges, then, yeah, right? Like if the series converges, then the integral should converge. So I think you can also do the integral test. I don't add it to my list. I don't want to do it, but I think you can do the integral test as well. All right. So that's a lot of random review, and we're done. So I'm going to see you in the next video when we start talking about probably something else, because these notes are done. So I will see you there.